Hi, this video is about preventive care of the motors. As you can see in the picture, the top part shows the motor stator here, the bottom part shows the rotor here, and this is the fan. Usually this fan is just connected to here at the end of the shaft. These are called the cooling fins. These are the inside of the motor winding, and when the power goes in, three-phase power applied here, due to induction this rotor rotate, and that's how motor basically run. Two ends there is a ball bearing one, and there is inside second ball bearing here. So mainly the failure on the motors, there can be two types basically, is the mechanical or electrical. The mechanical failures can be the breakdown of the ball bearing, or there is a shaft wear out of the shaft here, or and those kind of failures, broken cooling fan, there is a wear and tear of this key here. So those kind of are the mechanical failures. Electrical failures can be the breakdown of the insulation or short circuit of the insulation. So those are the electrical failures. So why we need to do the preventive care of the motors is pretty obvious. Lower production downtime and cost saving in the rewinding of the motors. So if the motor is burn out, or if you need to replace, if you're lucky there is a spare motor and you can replace it, but still that is take around like 2-3 hours, and if you don't have any spare motor, in that case it will be very significant production downtime. Some motors are very huge, like the motor used in the compressors and the boiler fans. Those are the very huge motor, and easily very expensive to keep the spare of those kind of motors. Second thing is the cost saving in the rewinding the motor is very significant cost involved in the rewinding of the motor. Like copper is very costly, so it's better to take the preventive care of the motors. Things to check periodically. From the mechanical point of view, you can see that, okay, make sure the motor installation is level and aligned. So if it's not aligned, you know that either your ball bearing is going to wear out, or your motor shaft will be wear out because of the misaligned. Usually you can periodically check the noise to detect the wear out of the motor shaft or any ball bearing. Make sure the cooling fan is working properly. Sometimes cooling fan is broken, and cooling fins, not proper air is going on the cooling fans here. These are the cooling fans where the motor fan is connected on that section, and it blows the air here. So make sure that cooling fan is working properly. Make sure the cooling vents and fins are clean. If you work in the textile industry, you know that a lot of cotton, they can stick to this kind of motor or block the vent or cover that protect the fan. So if those holes are filled with the cotton, then there won't be any proper circulation of the air. On the electrical side, periodically you want to use the properly rated fuses based on the motor capacity, motor ampere capacity. Make sure motor is properly earthed. That is like any prevent the fire hazard or any shock to the person. Make sure all the power connection are tight. So basically, as you can understand, when the power comes in from the circuit breaker, it go basically to the power bar. From power bar it go to the fuse, from their contactor, and then it goes to motor terminal. So there are lots of connection when the motor gets the power on. So make sure all the connection from source to destination is tight enough. Make sure motor amperes are within limits. It's a good idea to periodically check the motor amperes. You can use the clamp meter, or you can in-circuit ampere meters you can use, and make sure that motor amperes are within limit. If those amperes are going high, you know there is something wrong with the motor. Use the proper overload protection and make sure the trip mechanism working fine. Sometimes people do short circuit the overload, so even the overload trips, it don't cut off the power of the control circuit and don't stop the motor, and eventually motor end up burning. Make sure the thermal sensor working properly and the dealing and the displaying temperature correctly. So, and sometimes the thermocouple are used inside the motor, and those thermocouple are used to sense the temperature, and or you can use the thermal sensor outside, and you can measure the temperature of the motor periodically. Latest technology, the there is a LabVIEW software, and if you have so many motors, the LabVIEW software or properly written code in the LabVIEW, it can gather the temperature from all different motors, and if any motor gives any high temperature, it can alert you, or it can shut down that particular motor. So that's kind of very high-end technology, but that's possible to use the LabVIEW software to detect the temperature of the like 100 and 1000 of the motors. Periodically check the contacts of the contactor. Usually what happens that due to if motor operation is turning on and off, the contactors of the contact, there is a spark happen between two contacts, contacts of the contactor, and sometimes those contactor burn out, and out of 3 contactor contacts, maybe one is not properly shutting down, and that cause like unbalanced load, and that eventually cause motor to fail or motor to burn down. So hopefully this help you to make some of the points that you can check mechanically or electrically. Okay, thanks.